Mm-hmm. Yes, sir. So that means you need to get your feet up here. I use my board every day, so find you something here. You're gonna get a side seat soon. Yeah. Can't see. I don't like to hear I can't see or nothing like that. So you know, we old enough to know, hey, I need to sit up there. So wear your glasses. You wear glasses? See, all right? It reads integer exponents. So that's the first skill we're looking at in 8th grade math. The first thing it tells us to do is pay attention to the operation, the basis, and the exponents given. It then tells us to follow the rule noted. There are 5 different rules. Actually, there are 6. Cross that out and put there are 6 different rules. Where it has 5, you can erase it and say there are 6. There are 6 different rules. It tells us some problems will use more than one rule. Make sure you look at each one separately. So integer exponents, first thing we're looking at. At the bottom, we got a few vocabulary. This is some things we should know or maybe we don't know. Integers are all our whole numbers and their opposites. That is integers, whole numbers and their opposites. Or in other words, positive and negative numbers. The base, as we should know, that is the larger number in a problem with an exponent. In that variable problem, 9 was the base because it was the largest. Then, of course, the exponent. The exponent is the smaller number that's in the corner. It typically tells you how many times to multiply that base by itself. Any questions about it? Yeah. Jennifer? Olivia? All right, the first 2 rules. The first is multiplying powers with the same base. The second is dividing powers with the same base. With these rules, you definitely want to make sure you get the title of the rule and what it tells us the rule is, and of course, you need an example. Those examples are going to be able to easily help us identify what rule we're referencing. These are the first 2. All right, the first rule tells us multiplying powers with the same base. Base is which one, the big or the small? Big, good. So an example they gave us 5 to the 8th and 5 to the 5th. 5 is big both times, so clearly that's the base. So anytime I see that a problem got the same base and they are multiplying, this one they did parentheses with no sign. Anytime you see parentheses and no sign, it's multiplying. What else would they use to identify multiplication? The little dot and then the X. So make sure we know how to identify multiplication. So anytime we see the same base, just remember, add those exponents. 8 plus 5 gives us 13. Just that simple. These are the types of problems they're not going to ask you to solve it. They just want to know if you can simplify it, or in other words, change it from 2 to just 1. Then looking at the other one, divide powers with the same base. So anytime we are dividing with the same base, we're going to subtract the exponent. So they're opposite. Most of the time with division, they will not use the division symbol. They'll typically always use the fraction. So if you're not used to the fraction as division, please get used to it. So in this problem, 4 to the 12 divided by 4 to the 5th, clearly 12 minus 5 will give us 7. Any questions about these two? These are the two of the easiest, I think. Anybody else still right? All right, 3 and 4. 3 is product of powers and 4 is product of powers with different bases. You got a minute and a half or so. All right, the first one says product of powers. That's when you will pretty much have 2 exponents, or it look like 2 separate exponents. So anytime that happens, I just need to remember, instead of adding the exponents that time, I need to multiply them. So 3 to the 2nd power to the 4th power, that will tell me 2 times 4, which will give me 8. So the simplified expression will be 3 to the 8th power. Any questions about that rule? All right, the 4th one, product of powers with different bases. So sometimes the bases will be different, but notice the exponent is the same. So 2 to the 3rd times 4 to the 3rd, the exponent was the same. So then we would multiply those bases. 2 times 4 will give us 8. And then that exponent will still remain the same. Questions about that rule? Everybody got those two? All right, last two. Having an exponent of 0, and then that sixth one is negative exponents, and we kind of looked at it when we did work this morning. All right, so still moving. 0 exponent or exponent of 0. Pretty much self-explanatory, simplified to 1. 125 to the 0 power, there's 1. I don't care if it's 1,000 to the 0 power. Anytime you see 0 as an exponent, it's 1. Negative exponent, I said we looked at that for their work. Change the numerator to the reciprocal, or in other words, flip it, and then that exponent becomes negative. So 15 to the negative second power, it was a whole number. So we know 1 is beneath it. So then just flip it, 1 now on top, that exponent now becomes positive. The second example was when they give us a negative exponent on the bottom. It still works the same, it's negative. So I'm going to take the reciprocal, or in other words, flip it. So 8 is now coming to the top, and the exponent is now becoming positive. Questions about it? There's no matter. How many rules you got? You ready to try them out? All right. You can go ahead and get this problem down. For word problems, you don't have to write the word problem, but when they give us short little problems, yes, you need the problem, you need the work. I like to look at them as cheat sheets. Take good notes, you'll have something you can use when we're doing activities or we're doing a quiz or a test. You'll have something to refer to. Three to the second power times 4 to the second power, and then to the fifth power. Does anybody spot any rule so far? It's 2 in this problem. 3. Number 4. Why you say 3 times 4? Why? What rule is it? 4. What was the name of it? Okay, product of power. Same base. No, same exponent. So Kennedy told us we would multiply 3 times 4. They have the same exponent of 2. 3 times 4 gave us what? So now we have 12 to the second power, and 5 exponent is still on the outside. What possible rule might that be? Get the name with it. Product of power. So what are we going to do? So that will simplify to 12 to the 6th power. Any questions about what we just did? Before we simplify, at each step, I asked you one question. What question did I ask you? What rule? So as you work in these problems yourself, make sure before you even start doing anything, you ask yourself, what rule? Even I saw some of you flipping back to your notes. Good. Use those notes to help you get the correct rule so you won't get the incorrect answer. Questions? Everybody got what you need? Great job, ladies and gents, that attempted that, tried it with us. All right, let's have a look at this one. You don't have to worry about the end, just get the problem. 9 to the negative 8 times 1 to 9 to the third. Don't worry about the writing, just get that problem. 9 to the negative 8 times 1 to the negative third. Who that matter? So how we gonna write it now? 1/9. Good job. All right, what can we do with this? 1/9 thirds. You said 9 to the -3, and we're getting rid of the 1. Okay, so notice the whole thing they did, they took the reciprocal again. And remember, anytime we take the reciprocal, that exponent is going to change to the opposite. So if it's positive, it's now changing to negative. And I'm going to write it with the 1 over the bottom. So now we can take them back to multiplying fractions. Everything multiplied by 1 is 1. So now we have 9 to the -3rd being divided by 9 to the 8th. 9 to the -3rd being divided by 9 to the 8th. And I just told you your next rule. So what are we now going to do with those exponents? Sure divide? Good job. We got to subtract. So that takes us into -3 minus 8. Same sign, so let's add and keep the sign. So 3 plus 8, 11. So now we have 9 to the -11th power. Nine to the -11. All right, but this problem said write it with positive. So if I simplify and I still end up with a negative, now what am I going to do? Good job. Switch the next to the positive. So our answer will be 1 over 9 to the 11. Any questions? Any questions so far? All right. Everybody got what you need. Let's see if we can try another one. So far, so good. All right, don't worry about the writing, just get the problem. 45 to the -3rd divided by 45 to the 3rd. All right, she said they divided with the same base, subtract exponents. So that would be -3 minus 3. What would that give us? You sure? Positive or negative? It's one of negative, one of positive. So. And see, when we say subtract, notice I wrote that expression out. So if you need to write that expression out with those exponents to make sure we get it right, do so. -3 is on top, then put your minus sign and then do your next exponent. Anytime they have the same sign, add your numbers and keep your sign. So 3 plus 3? 6. Good job. So now we have 45 to the -6 side. It's a negative exponent. What are we going to do? Flip it. Good job. 45 to the 6. They said somebody chose 8. How do you think he could have possibly ended up with 8? Or what did he have done wrong? Been flipping? That could be 1. How do you think he could have got a -1 from -3 and 3? He probably made it. He divided. He did -3 divided by 3 to get -1. So when we are dividing with that same base, make sure you're not dividing your exponents. You subtract those exponents. Any questions about it? How many rules you got? 6. Everybody got what you need? All right, it's almost time to go. A quick cap about exit ticket homework.